Okay, let's unpack this. We all spend a huge amount of time indoors, right?
Oh, absolutely. Most of our lives, really.
And it might seem obvious, but the quality of the air in those buildings where we live, work, shop is incredibly important for our health and comfort.
Definitely. And because of that, building standards, guidelines, they're always evolving, always pushing to make that indoor air better.
And one of the really impactful areas of change right now, well, it focuses directly on how the air circulating in those buildings gets filtered.
We're talking about air filter standards. That's the core of it.
Exactly. So for this deep dive, we're focusing on a significant update in Australia, the AS 168.2.2024 standard,
hmm
and specifically how it now leans heavily on a global standard called ISO 16890 for rating air filters.
Yeah, and our goal here isn't just to, read you the standards chapter and verse.
No, not at all.
It's to explore what this shift actually means in practical terms for you, whether you're dealing with it in your own home or maybe managing a large commercial building.
Right. We've pulled together the key information to help you quickly grasp the essentials.
Let's do it.
All right, let's jump in with AS 168.2.2024. What is this Australian standard all about at its core?
Well, at its heart, AS 16668.2.2024 sets the rules for things like minimum fresh outdoor air intake in different building types.
Okay.
Think houses, big shopping centers, offices,
Hmm.
you name it. The fundamental aim is ensuring the air inside these spaces is safe and provides a comfortable environment.
In the material we looked at highlighted a couple of critical aspects within this standard.
Yes, it outlines minimum outdoor airflow rates.
Mm-hmm.
Those are often calculated based on, say, how many people are expected to be in a space or just the size of the area itself.
But the really big news, and what we're focusing on today.
Ah, yes, that's the specific requirement it now has for filtering air that's recirculated or treated within the building.
Right.
This is where the big change happens.
Mm.
The standard now requires filter performance to be assessed using ISO 16890.
Which immediately makes us ask, what is ISO 16090?
Okay, so ISO 16890 is the international standard. It's for testing and rating air filters. And unlike maybe some older methods, its core focus is on how effectively a filter captures particles based on their actual size.
And this particle size thing, that's pretty crucial, isn't it?
It's absolutely fundamental. You see, ISO 16890 defines efficiency across specific particle size groups.
Like what?
Well, first you have PM10. That covers particles 10 micrometers and smaller, think pollen, maybe larger dust particles.
Okay, PM10.
Then there's PM2.5. That's 2.5 micrometers and smaller. Now you're getting into things like smoke, finer dust, allergens.
Uh-huh.
And finally, PM1. These are the smallest of the regulated sizes, just 1 micrometer and below.
1 micrometer. What kind of things are that small?
Well, these can be combustion particles from vehicles. Some bacteria, even viruses, can sometimes fall into this range or attach to particles this size.
And the danger level goes up as the particles get smaller. Is that the idea?
Exactly. That's the key point here. The smaller the particle, the deeper it can penetrate into our respiratory system.
Right. Or deep.
PM 2.5 and especially PM1 particles can get right down into the deepest parts of the lungs. And kind of alarmingly, they can even cross over into the bloodstream.
And into the bloodstream. Wow.
That's why these sizes are so critical from a health perspective.
So how does ISO 6890 actually rate filters based on these sizes then?
It tests how well a filter removes particles within each of those three size ranges, PM10, PM2.5, and PM1.
Okay.
And it gives you a rating based on the percentage of particles removed. So say a filter rated ISO EPM 2.5 50%.
Right.
That means it's been tested and proven to remove at least 50% of particles that are 2.5 micrometers or smaller.
So it's quite clear, a percentage for each size range.
Exactly. You get a clear percentage for its effectiveness at tackling those specific health-relevant sizes.
Okay, here's where it gets really interesting, I think. This focus on PM sizes, percentages, tested internationally. It's a significant departure from what many people might be familiar with, especially maybe in the US or even Australia previously. I'm thinking of the MRV rating.
That's right. MRV, the minimum efficiency reporting value, that's been widely used for a long time, largely associated with the North American HHRE standard.
But the trend globally, and now officially in Australia with AS 1668.2.2024, is moving towards ISO 11690.
Yes, it is.
And when you compare them side by side, the differences are pretty clear.
Definitely. MRV, well, it's been around longer, originated in North America. ISO 16890 is the international standard.
And the rating system itself is different.
Yeah, MRV rates filter performance across a range of sizes, sure, from 0.3 to 10 micrometers. but it puts them into broader groups and gives you a single number, like MERV 8, MERV 13.
A scale from 1 to 16, usually.
Right. Whereas ISO, as we just discussed, gives you those specific percentage efficiencies for the health-critical PM10, PM2.5, and PM1 fractions.
But the really compelling difference, and maybe why ISO is seen as a step up for real-world application, what is it?
Ah, yes, it's the testing method. That's crucial.
How so?
Well, MRV testing is primarily done with synthetic dust in a lab setting, which is fine, but
But
ISO 16890 incorporates testing with real atmospheric dust.
Okay. Dust from the actual air.
Precisely. This is a really important distinction because it gives you a much more realistic picture of how that filter is actually going to perform in a real building.
Not just when it's brand new out of the box.
Exactly. But as it starts collecting the actual mix of particles found in the air we breathe indoors, it's just a better predictor of real-world performance.
Okay, that makes a lot of sense. So bringing back to the Australian standard, AS 1668.2.2024 is now specifically saying you must use filters rated this way. What's the minimum requirement it lays out?
The core rule, the absolute baseline, is that any air that's recirculated or filtered within these buildings must pass through a particulate filter with a minimum efficiency of ISO EPM 2.5 50%.
ISO EPM 2.5 50%. Why did the standard land on that specific requirement? What's the thinking behind focusing on PM 2.5 at 50%?
It seems to be a deliberate focus on the most impactful particles for general health in typical indoor settings.
Okay.
Mandating ISO EPM 2.5 50% means, first, they're requiring performance based on that more realistic ISO testing method we talked about.
Right, the real-world dust.
Yes. And by specifically targeting PM 2.5, which we know is linked to respiratory and cardiovascular issues. Well, the standard is explicitly pushing for better protection against the particles generally considered most harmful to human health in these common environments.
Okay, so if you're using filters that meet or, exceed this standard, whether for your home or your business, what are the tangible benefits? What can you expect? Let's start with someone thinking about their home.
For a home environment, it's pretty straightforward, really. Cleaner air.
Okay.
These filters are effective at capturing the everyday stuff like dust and pollen, sure, but also the more problematic things like smoke particles, allergens,
What you mean?
which means a healthier living space. It could potentially reduce symptoms for anyone with asthma or allergies.
That's a big plus.
Huge. And because the ISO ratings are percentages, they're often easier to understand than just a MERV number. You see, removes 50% of PM 2.5, and you kind of know what you're getting.
More intuitive.
A bit, yeah. And ultimately, just breathing cleaner air contributes to better sleep, overall comfort in your home.
Makes sense. And what about for businesses? Offices, retail spaces, things like that. What's in it for them?
Well, for businesses, the first benefit is pretty basic. Compliance. Meeting the updated AS 1668.2.2024 standard is now a legal requirement in many cases.
Right, gotta follow
You got to follow the rules. But beyond that, there are significant health benefits for the occupants, whether that's employees or customers. Better air quality can mean fewer sick days, maybe improved focus, productivity.
Okay, real bottom line benefits there.
Potentially, yes. And there are operational benefits, too. These filters protect the expensive HVAC equipment, other sensitive machinery maybe, from dust buildup. That can reduce maintenance costs over time.
And energy efficiency, does that play a role?
It can, but it requires careful system design. Choosing the appropriate filter, considering pressure drop, which we should talk about, can contribute to overall HVAC energy efficiency. It's not automatic, but it's possible.
Okay, pressure drop. We'll definitely circle back to that. But first, let's take a moment to delve a little deeper into PM1 again. We touched on it as the smallest size. Why is it so particularly important to understand how filters perform at this level, even if the minimum standard targets PM 2.5?
Right, so PM1 particles, less than 1 micrometer. As we said, they're the absolute tiniest and, frankly, the hardest for filters to capture effectively.
Where do they come from again?
Mostly high-temperature sources. Think car exhaust, bushfire smoke, industrial processes, and yes, sometimes things like viruses or bacteria can attach themselves to particles this small.
And their health impact is significant. You mentioned the bloodstream earlier.
It is. Because they are so incredibly small, PM1 particles can travel the deepest into the lungs, cross that barrier to the bloodstream, and they're linked to more severe long-term health issues.
Like what kind of issues?
Cardiovascular problems, serious respiratory diseases. The long-term exposure effects are a major concern.
So while the AS 1668.2 minimum is ISO EPM 2.5 50%,
Right.
Understanding the ISO ratings specifically for PM1 becomes really crucial if you want to target the most dangerous particles.
Exactly. You'll see ratings like ISO EPM1 50%, maybe EPM1 65%, EPM1 80%, or even higher. A higher percentage here means significantly better protection against those smallest, most harmful pollutants.
Okay, so we want efficiency, especially for PM2.5 and PM1 if possible. But you mentioned there's a balancing act involved, highlighted by something called pressure drop. What exactly is that, and why does it matter when choosing a filter?
Okay, pressure drop. It's simply the measure of how much the air pressure decreases as air passes through the filter.
Like resistance.
Exactly like resistance. Think of it as how hard the filter pushes back against the airflow.
So a low pressure drop is good, means less resistance.
Generally, yes. A low pressure drop means the fan in your HVAC system doesn't have to work as hard to push air through the filter.
Which uses less energy.
Less energy, yes, and puts less strain on the equipment itself. Conversely, a high-pressure drop means the system is working harder, using more electricity, and potentially even reducing the overall airflow, which could impact ventilation rates if it's too high.
And the ISO 16890 testing accounts for this.
It does. The standard actually requires measuring both efficiency and pressure drop simultaneously, so you get a more complete picture of the filter's performance characteristics.
And that's where the balance comes in. You hinted that higher efficiency filters often have higher pressure drop.
That's usually the trade-off, yes.
Right.
Filters designed to capture very small particles, like PM1 or high levels of PM2.5, typically have denser filter media.
Makes sense. More stuff to catch tiny things means it's harder for air to get through.
Precisely. That density increases the resistance to airflow. So while you gain better particle removal, which is good, you often incur a higher pressure drop, which uses more energy.
So the challenge is?
The challenge, especially in larger building systems, is choosing a filter that meets or exceeds the required efficiency, like that ISO EPM 2.5 50% minimum, without creating so much resistance that the HVAC system becomes inefficient, uses excessive energy, or maybe can't even deliver the required amount of airflow anymore.
All right, that's a crucial point. So for someone listening right now, trying to figure out what filter to buy or specify, what's the practical guidance? How do you choose the right filter balancing these factors?
Okay, based on what we've discussed, for a home, you should absolutely look for a filter clearly labeled with an ISO 16890 rating.
Step 1, find the ISO rating.
Yes, aim for at least ISO EPM 2.5 50%. That meets the baseline thinking in the new standard.
Okay. What if you have specific concerns?
Right. If you or family members have allergies, or maybe you live in an area with high pollution or near bushfire zones,
Yeah.
then considering a filter with an ISO EPM1 rating maybe 50% or higher would offer significantly better protection against those really fine particles.
But check the pressure drop.
Always. Check the pressure drop information provided by the manufacturer and try to ensure your specific home system can handle it without struggling too much.
Okay, good advice for home users. What about for businesses or larger buildings?
Well, for any commercial or public building in Australia covered by this standard, the absolute minimum is compliance with AS 1668.2.2024.
Which means?
Which means using filters rated at least ISO EPM 2.5 50%. That's the floor.
But some places might need more.
Definitely. For specific applications, think hospitals, laboratories, maybe sensitive manufacturing areas requiring very clean air. You'll absolutely need much higher ISO EPM1 ratings.
Yeah.
It could be 80%, 95%, or even more.
So for businesses, it's probably best to get professional help.
I would highly recommend it. Work with an HVAC professional. They can help select filters that not only meet the standards, but are also appropriate for the specific system's capabilities. They'll help balance those air quality goals, the energy use related to pressure drop, and ongoing maintenance needs.
Right, getting that whole picture.
Exactly. We saw a good example of this balance in the material we looked at, remember? Talking about a school in a busy urban environment.
Oh yeah, tell us about that.
They chose filters rated ISO EPM 2.5 65% and ISO EPM 1 50%.
So better than the minimum on PM 2.5 and also targeting PM1.
Right. This gave them good protection against both the general urban pollution, the PM 2.5 stuff, and also those finer traffic-related particles, the PM1.
But the crucial part.
The crucial part was their maintenance plan. It included regularly checking the pressure drop across those filters.
Making sure the system wasn't struggling.
Precisely. To ensure the HVAC system wasn't being overworked. It shows you can aim for high efficiency while still actively managing system performance and energy use.
That's a great practical illustration. Okay, so let's quickly pull together the key takeaways from this deep dive. What are the main things people should remember?
Okay, first and foremost, ASS 1668.2.2024 in Australia has made a significant change. It now requires filters to meet a minimum efficiency standard measured by ISO 16890,
And that minimum is,
at least ISO EPM 2.550%.
got it. And ISO 16890 is that important global standard because it tests filters based on actual particle sizes relevant to health, PM10, PM2.5, PM1.
And crucially, uses more realistic real-world conditions, including testing with actual atmospheric dust, not just lab dust.
Making it more relevant.
We think so, yes. And we now understand why PM1 and PM2.5 are the crucial particle sizes to focus on for health protection, given how deep they can get into the body.
Right, the bloodstream connection is pretty sobering.
It is. And remember, pressure drop. It's more than just a technical detail. It's a critical factor to consider alongside efficiency.
Because it directly impacts your HVAC system's energy consumption and potentially its lifespan.
Exactly right. And ultimately, understanding and using filters that meet these ISO standards brings real benefits: cleaner indoor air, improved health outcomes for occupants in both homes and businesses.
And potential operational savings for businesses, too. Okay, and just addressing a few quick points that often come up, sort of like FAQs. What happens if a building, maybe an older one, uses a filter below that ISO EPM 2.5 50% minimum?
Well, strictly speaking, it means the building is likely not compliant with the current AS 168.2.2024 standard.
And the consequences.
That could lead to significant indoor air quality issues for the occupants and potentially legal or regulatory problems for the building owner or manager.
Okay. And is getting the highest possible PM1 rating always the only goal? Should everyone just aim for ISO EPM1 99%?
Not necessarily. While higher PM1 efficiency is technically better for filtering the smallest particles, you always have to consider that balance we talked about with pressure drop.
Right.
The highest efficiency filter might not be the right choice if your specific HVAC system can't handle the resulting airflow resistance efficiently. It could actually harm the system or reduce ventilation.
Balance is key. And finally, how often should these filters be changed? Does using a high-efficiency filter change that?
Filter change frequency really varies. It depends heavily on the environment, how much pollution is in the air outside and inside, and how much the HVAC system is running.
So no single answer.
No single answer. However, it's important to check filters regularly, perhaps even more so with high-efficiency ones, because they capture more tiny particles. Their pressure drop can sometimes increase more quickly than lower efficiency filters.
Ah, so they might get clogged faster in a sense.
In a sense, yes.
Yeah.
So they might need more frequent checking or changes to maintain both optimal system performance and the desired air quality.
Good to know.
Stepping back, though, this move in AS 1668.2024 towards mandating ISO 16890 rated filters, it really feels like a positive step, a significant step forward for indoor air quality in Australia.
Why do you say that?
Because it puts the focus squarely on real-world performance and uses clear, health-based metrics. It's about ensuring the air inside our buildings is genuinely cleaner and healthier.
This has certainly opened my eyes to the sort of invisible science behind the air we breathe indoors every day. It makes you think, if we know that smaller particles, especially PM1, can reach deep into our lungs and even our bloodstream.
Yeah.
Doesn't understanding these particle sizes and filter efficiencies maybe change the way you think about the air everywhere you spend time? Not just in the buildings covered by codes, but, in your car, on public transport, even just choosing where you walk outside on a smoggy day.
That's a really interesting thought. It absolutely could.
It makes you consider the invisible world around us a bit more closely, doesn't it?